Today we will continue with the components of a vector, and then we will learn unit vectors, and finally we will finish with scalar and vector product. Why we need adding of vectors by using their components? Because adding vectors graphically, which we have learned during the last lecture, provides limited accuracy. So we will learn today how to add vectors by using their components. Here you see a vector, and this is x-axis, this is y-axis, and we would like to find or determine the x component and y component of this vector. This is very easy for you. You know already maybe from your high school years. So x component of this vector is given by a times cosine theta. And y component of this vector is given by a times sinus theta. So by using this a, y, and a x components, we can carry out vector addition, vector subtraction, and also we can use these components in vector products. So here, what do you see? A x and a y are positive because x component is along the positive x and y component is also along the positive y. Here, let me remind you that the components are not vectors. So here you see ax, this is magnitude, okay? So ax is magnitude along the x-axis. And a y is magnitude along the y-axis. So in order to have vector here, we have to add unit vectors. We will learn this one, okay? So this is vector, and it has certain magnitude and certain direction, but its components, x component and y component, are not vectors. We have just magnitudes, okay? In order to have vectors along the x-axis and y-axis associated with this a vector, you have to add unit vectors. We will see that. So now what I have told you here, that this ax and ay are positive because they are along the positive x and positive y, but they can also be negative. So here you can see it. Here we have a b vector, and this is the x-axis, this is the y-axis. This is the positive x direction, this is the positive y direction. What do you see here? Bx component of this b vector is negative because it is along the negative x direction, right? So bx is negative here. And what about by? By is positive because it is along the positive y direction. Let me remind you here, words, one is axis, the other one is direction. For example, this is x-axis, and x-axis has two directions, positive x direction, negative x direction. This is y-axis. It has two directions, positive y direction, negative y direction. Okay, so then let me continue with that example. Here we have a c vector. It has certain direction and it has a certain magnitude. And what about its components? X component here along the negative x direction. For this reason, x component of the c vector is negative. Then here we have y component of the c vector. It is also along the negative y direction. For this reason, this is also negative. So both components of this c vector are negative. Then how to calculate the components of a vector from its magnitude and direction? Let's consider that magnitude of a vector is given and direction is also given. And then we would like to calculate the components of a vector. So here we have two examples. This is the x-axis, this is the y-axis, and this is the d vector. It has certain direction and it has certain magnitude. it has x component along the positive x direction, and it has y component along the negative y direction. So here we see an alpha. You see the angle between the x-axis and d vector. I will discuss this one in the following transparency, but here I would like to say that angle alpha is measured in the wrong sense from the positive x-axis. So here in the calculations, if you would like to calculate dx, you should use d times cosine theta, right? If you consider this one. But if you use positive alpha here, you will get wrong result. I will discuss it. But first of all, I would like to take your attention. Again, here we have x-axis and y-axis. So let me also remind you here that you can draw the coordinate system as you wish. Here, you draw the coordinate system like this. You can also draw the coordinate system like this, as you wish. It depends on you. So here we have E vector. It has certain direction and magnitude, and this is the EX component along the positive X, and then this is the EY component along the positive Y. So here you see the angle theta from the x-axis to the E vector. And here you see another angle from the y-axis to the E vector, which is beta. So angle beta is measured from the positive y-axis, not from the positive x-axis. So you must be very careful with the angles within the questions. Otherwise, you can get wrong results. I will discuss it here. So we must use theta, which is measured from the positive x-axis toward the positive y-axis. So now let's have a look what I mean. Here we have an example, finding components. What are the x and y components of vector d here? D given, and the question asks that what is the components of d vector? What is dx and what is dy? The magnitude of the vector is 3 meters. Magnitude of the d vector is given. And then angle alpha is 45 degrees. This is the angle from x-axis to the d vector here. But look at the coordinate system. X-axis is this one, y-axis this one, and alpha is from positive x to the negative y. And if you use that alpha value in your calculations, you will get wrong result. I will explain why. So in the B of the question, what are the x and y components of vector E? Here we have a vector E, and x and y components are asked, and magnitude of vector E is given with 4.5 meter. Magnitude is given. And angle beta is also given 37 degrees. Beta is 37 degrees. So now let's consider that you are using that relation here. This is the AX is given by A cosine theta, I mean X component, and Y component is given by A sinus theta. So here, let me choose the pen. To find the dx, if you write here, dx is equal to d times cosine theta, and dy is equal to d times sinus theta, right? From this information. You see, I'm showing you the wrong example, okay? So you would like to calculate dx. Now, let's continue. What is the magnitude of d? 3 meter. Just put 3 meter here. And then you think that angle is given, and you are just using cosine 45. and you will get wrong result. Okay? You will get wrong result. You cannot use positive 45 degrees here. You have to use negative 45 degrees. Okay? Because look at the alpha. Here, alpha is 45 degrees. So if you would like to calculate this component, you have to use negative 45 as it has been done here, and result is plus 2.1 meter. In order to calculate the y, again, you have to take sinus minus 45 degrees, and then you will get negative value for the dy, because look at the picture. This is the y-axis, and dy is along the negative y direction. So this component must be negative, right? But if you put here positive, then you will get positive number. So this is very important during that calculations. Let me clear this part. Okay, it is also same for the E vector. Magnitude of the E vector is given and beta angle is given. What is beta angle? Beta angle is this one from y-axis to the vector. But we must use theta, which is measured from the positive x-axis toward the y. So you know the beta from the 90 degrees relation. You can calculate the theta. Theta is 53 degrees. So you have to use cosine 53, sinus 53 in your calculations. Okay, so you must be very careful when you are dealing with these things. So this was a short example. Then let me continue with the properties of the components and how to use components in your calculations. During the last lecture, we have used trigonometry and Pythagoras theorem, right? So you would like to find a vector's magnitude and direction from its components. So magnitude can be calculated like this. You have a vector here, okay, and you have x component and y component. You would like to calculate the magnitude of the a, and you would like to calculate theta. So you don't know the magnitude of the a, and you also don't know the theta. Let me draw here. This is the y-axis, this is the x-axis, this is the positive x direction, this is the positive y direction, and here I have a vector, okay, and here we have theta angle. In the question, x component is given and y component is given, okay, and question asks what is the magnitude of a vector and what is this angle. So you can calculate magnitude and direction from the components of this a vector. So you can do it like this. A square is equal to ax squared plus ay squared from the Pythagorean theorem. So how to calculate theta? We have done also this one during the last lecture. Tangent theta, this one, this angle is given by a y component over a x component like this one. If you take the theta from that equation, you will get r tangent a y over a x. So by using components, you can calculate both magnitude and theta. Okay, for this reason, vector components are very important. Now, let me remind you again another important point, which angle is correct. Here, mathematically, you can calculate the theta, but is theta correct or not? So it can be like this. There are different situations. Let me draw again. You did a calculation and you find a theta value, but is it correct or not? How to check it? I will talk about this. So let me draw another one. Theta is the angle between positive x-axis and the vector. So then let me draw another one. So here, by using the vector components a, y, and ax, I can calculate the theta, right? It is clear. So is theta is correct in physically or not? How to check it? So you can find theta like this. You can find theta like this. You can find theta like this. Which one is correct? So how to know this one? Here we have an example. Let's consider that tangent theta is equal to ay over ax is equal to -1. So you know the y component of the a vector. You know the x component of the a vector. Y component is given, x component is given, y component is -2, you put it there, and x component is +2, put it there. So result is -1, right? But what is theta? So if you run your calculator, two angles have tangents of -1. One is 135 degrees, you will get for the theta, and the other one is 315 degrees, this one, this is the theta. Okay, so which one is correct? You can easily understand. If theta is 135, let me draw. And after drawing, I will explain. So x and y components of a vector are given, and then they are given as 2 meters and -2 meters, and you put them here. So you get tangent theta is -1. So if you solve theta, arc tangent -1, and if you run the calculator, you can find two angles, 135 degrees, this one, and 315 degrees, this one. Which one is correct? So how to understand from the components to give your correct answer? So the correct answer is this one, because a y component is negative y. This is the y-axis, and this is negative y. This is positive x. If you take 135 degrees, then you will have a vector here, and then a y component will be positive now. But actually a y is negative. It is given in the question. And ax will be negative, but in the question, ax is given as positive, okay? So you must be very careful when you are calculating the theta. Is it clear now?
Yes.
Okay, thank you. So another property of the components, how to multiply a vector by a scalar. We have already discussed this one during the last lecture. Here we have a vector, and then I multiply this a vector with a c, a scalar number, for example, 2 or 3 or 5 or 1.5, okay? I have a vector and scalar number. I multiply this vector with the scalar number. So the result will be another vector, okay? And this vector will be c times bigger or larger than this initial a vector, right? We have discussed this one during the last lecture. But this vector has components along the x-axis and y-axis. This a vector has also components along the x-axis and y-axis, right? So what about the x and the y? If you multiply this a vector with c, it means that the final vector d will be like this. Its the x component will be c times x component of a, and its y component will be c times y component of a. So if you multiply a vector with a scalar number, it means that you also multiply its components with the same number. This is another important property of the components. Now let me discuss the last one, the third one, using components to calculate vector sum or resultant of two or more vectors. So what I mean, here there is x-axis and here there is y-axis, okay? And I have two vectors. One is a vector here. Can you see it? A vector here, and then b vector here. So what is the resultant vector? We have learned during the last lecture that we can add these two vectors graphically by using head-to-tail method, head of A and tail of B. By using head-to-tail method, I can get R vector, resultant vector, right? But this third item tells us that we can also do this one by using the components of the vectors. Here I have A vector. This is the AX, X component of the A vector. This is the AY, Y component of the A vector. And here I have B vector. This is the BX, X component of B. And here we have BY, Y component of the B vector. Then what about Rx, X component of the resultant vector? X component of the resultant vector is given by Rx, which is X plus Bx. And here our Y component of the R vector is given by AY plus BY. So here I can write like this: Rx resultant vector, the resultant component along the X axis is given by X component of each vector, and resultant Y component of the R vector is given by Y components of each vectors. Do you have any question here? In the book, in page 41, there is a problem-solving strategy related to that topic, how to use components in vectors, okay? I strongly suggest you to read that part. Okay, here, up to now, I have shown you the vectors in 2 dimensions, in x-axis and y-axis, but generally we use vectors in 3 dimensions. So we have x-axis, we have y-axis, and we have z-axis, okay? So if you have a 3-dimensional vector like this, a vector, it has x component, it has y component. In addition to that, it has z component, okay? Again, you can calculate magnitude by using that relation. A square is equal to square of its x component plus square of its y component plus square of its z component. Is it clear? Now let me continue with the unit vectors, very important in calculations. In Turkish, birim vector, okay? Why birim vector? Because a unit vector has a magnitude of 1 with no units. For example, here we have positive x direction, positive y direction, positive z direction, and we have unit vectors along the positive x, and we have unit vector along the positive y direction. We have unit vector along the positive z direction. They have magnitude of 1, don't forget. And the unit vector I points in the positive x direction, like this, unit vector here, and j points in the positive y direction. The magnitude is 1, the magnitude is 1, only their directions are different and they are perpendicular to each other because x-axis and y-axis are perpendicular to each other. And we have also k in the positive z direction. K is the unit vector along the z-axis, positive z direction, okay? So these are the unit vectors. So now let's combine the components of the vectors and unit vectors. So what I have told you, let me go back here. Components are not vectors. A x component, a y components are the magnitudes of the a vector along the x direction and y direction, okay? These are not the vectors. In order to have vectors along these directions, we have to use unit vectors. Now we are dealing with this one, okay? A vector here you have. This is a x component, a y component. But if you would like to have vector along the x-axis, you have to multiply this ax with unit vector along the positive x direction. Okay, so I can write this a vector like this: ax times I unit vector along the positive x direction plus ay times j unit vector along the positive y direction. If you have a three-dimensional vector like this one, we have three components, and then this vector can be represented like this: ax times I unit vector plus ay times j unit vector plus az times k unit vector. So component along the positive x direction, component along the y direction, component along the z direction. Do you have any question here concerning unit vectors? I have another figure which shows unit vectors together. This is the x-axis, this is the y-axis, this is the z-axis. So look at the picture. Here x-axis and y-axis are here, and here x is here, y is here, z here. Okay, you can choose any coordinate system, it doesn't matter. So now let's discuss this example and let's try to use unit vectors. Here we have two displacement which are given with d and e. Displacement d is given with that expression: 6 times I plus 3 times j minus 1 times k. So what is the meaning of that? It is three-dimensional vector. Let me draw it here. I prefer to have such coordinate axis, x, y, z, let's say. So along the x-axis, we have 6. Along the y-axis, we have 3, half of it, more or less. I have chosen positive y direction here. You can also choose positive y here, it doesn't matter. But you must be very careful. It depends on your choice. So here, negative number along the z here, 1. Okay, you can consider that this is the d vector. With the same method, you can also draw the e vector. It has 4 along the positive x-axis, and it has minus 5 along the negative y direction, and it has 8 along the positive z direction. So the question is that, what is the magnitude of the displacement 2d minus e? So this is the displacement f, 2d minus e. So how to find this f, this displacement, as in the question, by using these components. So by using components, you can find this one easily. So first of all, multiply d vector with 2 times d vector minus e vector. Put e vector here. So you have to multiply each component. We have discussed this one. If you multiply a vector with some certain scalar number, you have to multiply each component with that numbers. And then here what we have: I, j, k, I, j, k. And add these i's to each other, add these j's to each other, and add these k's to each other. Finally, you will have this resultant vector, total displacement f, as within the question. So now f is given by 8i plus 11j minus 10k meter. Okay, this is the total displacement, but the question asks the magnitude. Now we have the vector. This is not the magnitude, okay? So what is the magnitude? Magnitude can be written like this: f square is equal to fx square plus fy square plus fz square. So you know the fx is 8, fy is 11, and fz is 10. Put them here, then finally you will find the magnitude. Is it okay? Any question here? So now let's continue with the scalar product of two vectors. The name is scalar product or dot product. You see there's a dot, okay? Dot product or scalar product. So here we have two vectors, a vector and b vector. Just place these two vectors tail to tail, tail of a, tail of b, and there's a phi angle in between. So if you would like to get A dot B, you will get this result. So now A dot B equals to A times B cosine phi. Here we have A vector and we have component of B in the direction of the A, B cosine phi. If you take the B cosine phi, you will get the component of B along the A vector, okay? So this is the A dot B, or scalar product of two vectors. So it is written like this, A times B cosine phi. So here A and B are the magnitudes of the vectors, and phi is the angle in between. You can also do like this. You can write B times A cosine phi. The result will not change, okay? Here we have B, and here we have the component of A in the direction of the B. This is the A vector. If you take the component of this A vector along the B vector, you will get A cosine phi. So you can write in this form, or you can write in this form. So the result is this one. This is dot product of vectors A and B. Do we have any question here? Okay, this is very important. I have forgot to mention. Here we have a vector, and here we have another vector, and here we don't have vector. The result of the scalar product is a scalar, okay? The result is scalar. The result is not a vector. Don't forget this one. Any question? Now let me continue. The scalar product, so the solution of this one, the result of this one can be positive, can be negative, or it can be zero, okay? It depends on the angle here in between. So here we have A vector, here we have B vector, and here we have phi angle in between. So depending on the phi angle, it can be positive, negative, or zero. So let's have a look. Here, phi angle is less than 90 degrees. So it is between 0 and 90 degrees. We know that cosine phi is positive in this range, you know, from the trigonometry, right? So then the result will be positive. Look at this one. Is bigger than 90 degrees, and the phi is between 90 and 180 degrees. So in this range, cosine phi will give us a negative number. Then the result will be negative. Look at this one. Here we have 90 degrees between A and B vectors. Phi is 90 degrees. Then if you put cosine 90, then the result of the scalar product will be 0. Okay, because B here, B vector, has 0 component in the direction of the A. Okay, B has only component along this direction, perpendicular to the A. So B has no component here. Then let me continue about the components. You have a scalar product and how to deal with the components. The scalar product of two vectors like this, here I have an A vector, here a B vector. I can write the scalar product of these two vectors is the sum of products, okay? So here I have a x component of A vector, here I have a y component of the A vector, a z component of the A vector, and then I have components of the B vector. So scalar product of these A and B vectors can be written like this. Components of A and B, components of A and B along the y, components of the A and B along the z. Okay, so how to write this one, I will explain now. But again, I would like to take your attention here. A is vector, B is also vector, right? Look at the result. There is no vector on the right side. The result of scalar product is a scalar. It is not a vector. As I have told you here, the result of a scalar product is a scalar, not a vector. Now let me show you how this equation can be possible. So I have A vector and B vector, and I have scalar product. Just write A vector here with its three components, AX times I plus AY times J plus AZ times K, dot Bx times I plus By times J plus Bz times K. So you write all components along the X, Y, and Z, and then multiply this one with this one, multiply this one with this one, and multiply this one with this one. You will get this result. So you will have, look at this one, I times I times J, I times K components, J times I, J times J, J times K, K times I. You will have many components, but we have a general rule. I times I and J times J and K times K will give us 1. Okay, you have unit vector along this direction. You have another unit vector. Let me draw, you will better understand. So if you multiply two vectors along the positive X direction, just try to do that. I dot another unit vector is equal to magnitude of this one. Since these are the unit vectors, 1 times 1, and the angle in between, cosine phi. And the angle in between is 0. And cosine 0 is 1. So result is 1, right? So you can also do that for J dot J, K dot K, result will be 1. But if you multiply I times J, unit vector 1 times 1, both has magnitude of 1. But what about the angle in between? This is the I, this is the J. The angle in between is 90 degrees. I dot J. I has magnitude of 1, J has magnitude of 1, and the angle between the I and J is 90 degrees. So cosine phi is cosine 90, and cosine 90 is 0. So each component here, for example, Ji or AK or Ki or Kj, what else? Here we have Ik, Ij, all these components will give us 0, okay, due to that condition, 90 degrees in between. Here we have between I and between J, we have 90 degrees, and between J, between K, we have 90 degrees, between I and between K, we have 90 degrees. So this will give us 0. So I can omit all that components. So finally, I will have this component. So if you go back, the result will be like this. A dot B can be written AX times BX plus AY times BY plus BZ times BZ. Is it okay? Do you have any question related to that part? Now let's have a look example. This is another example from the book, finding an angle using the scalar product. So here we have A vector and we have B vector. And the question is that find the angle between the vectors. What is the angle between the vectors? So how to find the angle? You can use that relation. This is the scalar product of A and B vectors, right? If I know this result, if I know this one, magnitude of A and B, I can calculate phi angle, right? And the question asks, what is the angle? So I can find it. So first of all, I have to find this one, and then I have to find this one, then put within that relation, and then calculate phi angle. So here, look at the equation. Cosine phi, if you take cosine phi here, you will get scalar product of A and B vectors over A times B, magnitude of the A and B vectors. So this scalar product can be written like this. AX times BX plus AY times BY plus AZ times BZ. this one. Okay, just take this one and put it there. So how to calculate A times B? A can be calculated like this. B can be calculated like this. These are the magnitudes of the A and B vectors, and take them, put it there. Okay, so now here, first of all, we have to calculate this one here. AX, BX. What is AX? AX is 2. Let me choose another pen. This is the AX, this is the BX. Plus 2 minus 4. And what is AY? AY is this one. BY is this one. AZ is this one. BZ is this one. So put them here. Finally, we will get this relation, minus 3. Okay? So just put here minus 3. And we need A times B. Calculate A with that relation. Put AX, AY, and AZ components here, and then calculate. We have this result. Calculate B, we have this result, and put them here. Then finally, we will get this result for the cosine phi. And by using calculator, you can get phi angle is 100 degrees. Okay, do you have any question here? Now let's continue with the cross product. We have scalar product and vector product. Vector product is also called as cross product. You know, you also remember scalar product is called as dot product. Now we have A vector and B vector, and the vector product or cross product, cross this one, okay? Cross product of these two vectors will give us another vector. Remember the scalar product. You have vector, and the dot product of these two vectors is a scalar, not a vector. But in case of vector product or cross product, you have two vectors, and the cross product of these two vectors is again a vector. Okay, don't forget this. And here we have magnitude of this vector. Okay, this is just magnitude. Magnitude is given by A times B times sinus phi. Again, I would like to remind you that within the scalar product, we have A times B times cosine phi. And in vector product, we have A times B times sinus phi. Okay? And this is just magnitude of this vector. Don't forget, the resultant vector in vector product is a vector again. So now, how to calculate this resultant vector? Direction of the vector product can be found using right-hand rule. So how to do that? Here I have A vector and B vector. And there is angle in between. The angle is named by phi. So phi angle here. So what is C? What is A cross B? Have to find this one. Can you see my hand? Let's consider that this is the A vector, okay? And this is the B vector. First of all, point your fingers along the A vector, okay? And then rotate your fingers to the B vector here. And this thumb, this one, will show you the resultant C vector, okay? A vector is this one, B vector is this one, and you would like to find the direction of the resultant C vector. So first of all, you point your fingers, these 4 fingers, along the A vector, and then rotate them to the B vector, and this thumb will show you resultant C vector. But you have to use your right hand, okay, not left hand. Don't forget, always use your right hand. The rule is right hand rule. Do you have any question here? Everybody should understand this point.
Hocam eliniz kameranın biraz altında kaldı da bir daha üstü anlatabilir misiniz?
Tabii ki. I have A vector and let's consider this is the B vector. From my hand to my face, okay? B vector is this one, and A vector is this one. By using right-hand rule, first of all, I point my these 4 fingers along the A vector, and then I curl them to the B vector. Then this my thumb will show us the resultant C vector. Is it okay now?
Yes, I get it.
Okay, nice. Another property of the vector product that it is anticommutative. So you can write like this. This is the A cross B, and I can write this one like minus B cross A. So now let's try B cross A. B vector, can you see from the camera? B vector is from screen to my face, okay? This is the B vector, and A vector is staying here, and I would like to calculate B cross A. So B is this one, use right hand, and my 4 fingers will show the direction of the B, and then curl them to the A vector here. So the thumb, the direction of my thumb will show the direction of the resultant vector. Is it clear?
Yes.
But what we have seen, A cross B here has direction like this. Okay, but B cross A has direction opposite to this one. So if I put minus here, then this will also be along this direction, okay? Or if I put minus here, minus A cross B will be like this. So I mean this one, look at my hand. So this is the A vector and this is the B vector. And I am trying to find the vector product, the resultant vector of the vector product. So I curl my fingers from A to B, and then the A cross B is this one, okay? But if I calculate B cross A, it will be like this. This is the direction of the B cross A. So they are opposite to each other. If you put a minus here, they can be converted to each other. For this reason, the vector product is anticommutative. Do you have any question here? Now, how to find the magnitude of the vector product of 2 vectors? This is the resultant C vector, and it has certain magnitude. As I told you, magnitude is given by A times B times sinus phi. Now, we will go a little bit into detail. So, magnitude of A cross B equals to AB sinus theta. So A vector and component of B perpendicular to A. This is the B vector. If you take the component of B perpendicular to A, okay, component of B perpendicular to A, this is the magnitude of A cross B. Here again, this can be written like this, B times A sinus phi. It means that component of B vector and also component of this A vector perpendicular to the B. This will give us magnitude of A cross B. So both of them will give us this result, AB sinus phi. Look at AB sinus phi. B A sinus phi, so result is same, okay? A B sinus phi. Let me continue with the calculations by using the components in the vector product. So here I have A vector and B vector, and I would like to calculate A cross B. This is the A vector, look at carefully. A xi plus a yj plus a zk, okay, A vector. And here I write the B vector. Here I have a cross sign, bxi plus byj plus bzk. So then I will multiply this one with this one. I will multiply with this one with this one. But all multiplications will be cross product, okay? What do we have here? axi cross bxi, axi cross byj. AXI cross BZK. So again, multiply this one. Okay, multiply this one. So then you have result here. So just look at this rule here. This is I vector, this is J vector, this is K vector. Now, remember the rule. I would like to calculate this one. I cross J is equal to I is 1 and J is 1. I mean magnitude of J is 1. And the angle between I and J is 90 degrees, sinus 90 degrees, right? This is cross product. What is sinus 90? Sinus 90 is 1. So result is 1, but result must be vector. In cross product, result must be vector, but what about direction? Use right-hand rule. First of all, let me draw maybe if I can. First of all, draw your fingers. Let's consider right hand. Point your fingers along the I and then curl them to the J. Then this thumb here will show you the direction of the resultant vector. This is K, okay? So the result is K. So here I have summary. I cross J is equal to K unit vector. J cross K is equal to I unit vector. K cross I equal to J unit vector. You can do it by yourself, okay? These are the main results. Since vector product is anticommutative, so instead of I cross J, you can write minus J cross I, so they will be same. And J cross K will be equal to minus K cross J, and it is equal to I. So you can do it like this. So within that calculations, so I cross I, look at I cross I vector here, and another I vector here. So what is the angle in between? Angle is 0, sinus 0 is 0, then this component will be 0. So J cross J, this component will be 0. K cross K, this component will be 0. So you will collect other components. So finally, you will get this result. A cross B will be like this. AZ BZ minus AZ BY times I unit vector. AZ BX minus AX BZ cross J unit vector. Okay, and AX BY minus AY BX K unit vector along the Z axis. So the resultant vector is C. Let me draw. So the resultant vector is C. I can write here. It is also a vector, right? So what about the components of this vector? This C vector can be written like this. Cx I plus Cy J plus Cz K. Okay, so here this is the Cx, this is the Cy, this is the Cz. Okay, I can write them like this. Is it clear? Any question here? Then let me continue. I have almost finished. So this is my last transparency. Calculating the vector product. This is example 111 from the book. So let's read the question first of all, and then try to solve it. So what do you see here? Identify, set up, execute, evaluate. This is the style of the book. Okay, here, question, solution, identify, set up, execute, evaluate. Remember my first transparencies from the last lecture. Identify, set up, execute, evaluate, okay? This is the solution style of the Young and Freedman in the university physics, okay? So first of all, you have question. In the identification, you see that what do you have, what is given, and what is the target, and then you produce a setup. You remember the formula, which formula can help you, okay? You set up your problem, and then here you use the mathematics, okay? You execute your results, And at the end, you have to evaluate your result, whether it is correct or not. This is the style of the book. I have discussed this one during the first lecture, so I will not go into detail. So with that transparency, last example, I will finish the lecture today. After the lecture, please remind me that we will discuss the quiz and also we will have attendance list. So now, question. Vector A has magnitude 6 units, is in the direction of the positive x-axis. Here we have x-axis, y-axis, z-axis. And vector A is along the direction of the positive x, and magnitude is 6 units here. And vector B has magnitude 4 units and lies in the xy plane. This is x-axis, this is y-axis, this is the xy plane, and B is along the xy plane, okay? Perpendicular to the z-axis. This xy plane is perpendicular to the z-axis. Be careful. So making an angle of 30 degrees with the positive x-axis. This is the angle between B and A vectors, 30 degrees. So find the vector product A cross B, okay? A cross B, C is asked. So what about the direction of the result, C vector? So first of all, point your 4 fingers, if you can see from the camera, 4 fingers along the A vector and then curl them to the B. So thumb will show us the direction of the resultant vector. Okay, so by using the right-hand rule, I can find the direction of the C vector. So C vector is perpendicular to the A vector and B vector, perpendicular to the XY plane. So what was the question? Find the vector product. So you have to calculate this one. We have this relation, AB sinus phi. So this is the magnitude of this result, but not the vector, okay? In order to have the vector, we have to find x component, y component, and z component, and also we have to find the direction of the vector. So now let's start with that solution. The magnitude of the vector product is A times B sinus phi. A is given 6, put it there. B is given 4, put it there. Angle in between is given 30 degrees. Take the sinus 30 and the result is 12. Okay? By using right-hand rule, so the direction of the unit vector is k. So then C vector will be A cross B, which is equal to 12k magnitude. We have already calculated, and direction. Good. So this is the result. We have already solved the problem, okay? But we can also solve this one in the other way. How to do that? Look at this one. In order to calculate Cx, x component of C vector, you can use this relation, AY BZ minus AZ BZ. You can calculate Y component. You can calculate Z component. So now look at the question. What is the x component of A vector? X component of A vector is 6. What about the Y component of the A vector? A vector is along the positive x direction. For this reason, it has no component along the y direction. It is 0. And A vector has also no component along the z direction, and AZ is also 0. What about Bx? The x component of B vector along the x direction is given by 4 magnitude of B times cosine phi. So then we have this number. Y component of B vector, 4 times sinus 30 degrees. Then what about Z component of B vector? B vector has no component along the Z axis. Okay, so then it is 0. So then just takes this AX, AY, AZ, BX, BY, BZ, and then put them here. Okay, then you can calculate Cx, Cy, Cz. Okay, Cx, Cy, Cz. then the result is 12. We have only z component for the c vector, okay? Y component and x components are 0 because the vector product of A and B will give us vector along the z-axis, along the positive z direction. For this reason, this vector has no component along the x. This vector has no component along the y. It has only component along the z-axis. For this reason, it has magnitude 12 and the direction is k, okay? So both methods give the same result. Here we have already calculated 12k by using this equation. Depending on the situation, one or the other of two approaches may be the more convenient one to use. So during the exam or during the quiz, you can use this solution or you can prefer this solution. It depends on you. Do you have any question? With this one, I have finished my lecture related to the chapter 1 of university physics. And next week, we will continue with chapter 2.